So this is just going to be really fast because I know it's been a long day, and none of this is going to be new to you if you've paid attention throughout the whole of the meeting, because you've heard everything in here at one time or another. But it's just an overview of all the things that are going on at various stages of development, which we have the pleasure of watching on the Science Steering Committee, and hopefully bringing exciting things to everyone in the audience over the next several years. We do know that some things are definitely happening. Next year, in fact, Keck Planet Finder on track for 2022 commissioning, and the KCRM instrument, which will be the red channel of KCWI, will be also on track for commissioning in 2022, at least the last time I heard. Recently, we've had a successful installation of a new detector for low-res red side, which is this, you can see in the curve on the right. I have things covering it on my screen, but that is an actual QE curve of the blue side and red side together. So you can see they complement each other nicely. And this is just has been installed a few months ago. And of course, there are all the exciting upgrades to the AO system, Kappa. Those are things that are happening. Let me see. I don't know how to advance a slide here. It's okay, just clicking. Okay. So let me just say that mostly what I'm telling you about is activities related to the call for white papers, which happened this past June. And we had 13 proposals submitted and received last year. It was 14 this year, broken down into various categories. 3 were phase A studies, each of which was asking for more or less all of the money we had available in that category. 4 proposal development proposals, that is, things that have been blessed in the past, which are gearing up to submit to funding agencies or foundations. 3 mini grants and 4 concept studies. So that's not too bad from a relatively small community. And there's been a lot of demand and a lot of need for relatively small amounts of money, but this is a crucial stage of things, of course, in the sort of initial stages of design, and funding agencies won't pay any attention to you unless you've spent a fair amount up front to find out what the cost really is and whether it can be done. Instruments on a longer horizon, which you probably all know about, and you've heard about some of them in breakout sessions. Of course, LIGER, high spec, scales, FOBOS, and HACA, and I'll say a little bit more about most of these. LIGER, of course, has a very mature design, thanks to years and years of work on IRIS for TMT that went behind the design for LIGER, and they're basically in a stage where they're preparing, or I guess they submitted as of today or sometime very soon, a proposal for the full cost to complete the construction of the instrument. So that would be very exciting if that comes through. High spec is at a similar stage. It's a single mode fiber fed high resolution near infrared spectrometer. It's optimized for exoplanets. We have recommended also submission of NSF proposals. It didn't happen this year, but presumably it will be attempted again next year. And in the meantime, design work continues with available resources. Scales is a 2 to 5 micron integral field spectrograph optimized for exoplanets. You can see a table here from their proposal of all the modes and things that it brings to the table, and kind of attached to this, I'm not even sure if it was the choice of the proposers to think about it, but an imaging channel is being considered, and they're very fairly complex reasoning behind this, but the idea is to try to consolidate our resources and maybe have a replacement for NERC2, because scales would go presumably on Keck 2. But it is going forward with design work while seeking funds to complete it. FOBOS, you might have just heard about if you were in the FOBOS breakout session. Very ambitious instrument, and they've been supported with phase A money from the observatory the past 2 years, and this year they're gearing up for preparing a proposal to support major development effort over the next few years. So it's still high on our list of priorities. It's just that there are very few funding opportunities where the amount of money being discussed are enough to make really strong headway. But there's hope. Since we haven't heard anything yet, there's hope that the decadal survey might turn this around. We'll see. DEIMOS detector upgrade will happen. The CCDs have been selected and a quote has been received. And the only problem is finding all the money necessary. Long story about that, but not one for today. But you can see that the gains relative to the current DEIMOS are really pretty huge, especially out toward a micron. So these are really the optimal red optimized detectors. One of the larger future instrument being studied at the moment is a wide field imager. This is at prime focus with about a 1 degree field. And unlike all other wide field imagers, it would be sensitive in the ultraviolet. And it basically beats anything else out there by a factor of 2 or 3, all the way out to the Z band or so. And it has a fairly wide science case, and it's the kind of thing that results from thinking about where Keck wants to be positioning itself in the TMT era or over the next 10 years, whichever you prefer to think about. We're on another level, we're concerned about aging instruments and with the fact that they could very well fall apart catastrophically at any moment. And we'd like to have a plan for how to proceed in order to head that off at the pass. So there's been a desire to have a study of concepts for an instrument to replace LRIS at the CAS location on Keck 1. And it is possible to build a new and vastly improved LRIS-like instrument that does all of the same kinds of things, that is everything, but it would have an on-axis field of view, and it could be compatible with future GLAO. And the throughput is an improvement over even a very high throughput instrument of about 50% across the board. There's still studying of the adaptive secondary mirror technology. This is taking place at UCO with collaboration in a European company, TNO. And basically, have to start thinking about how we would use an adaptive secondary for all of our future AO systems. So far, it's clear that this is the way to go for GLAO, but it's less clear how it might interact with other AO systems architectures. There were several smaller proposals that were recommended for funding by the SSC. A new wavefront sensor to work with NERC2 called KPIC Fast, Visible Light AO Roadmap. And this is at some level motivated by the possibility of this ORCAS satellite, which is basically a down-looking, very bright laser beacon that can be used for extreme AO correction. And then some significant improvements to OSIRIS, especially software and diagnosing issues that are lingering, was recommended. This is just a picture of ORCAS, and it's kind of interesting. It promises to be, you know, if Keck remains involved, it promises to actually have benefits for the observatory other than just the use of this laser beacon, but it could have impact in instrumentation as well. But this is all things that we'll not know about for another, I don't know how long it is, 6 months or so. Other small things, AO operations working group. I don't know if that came up at this science meeting, but the proposal was to form a community working group, not to study future AO, but to study AO performance now and develop tools for monitoring performance of the AO system. And we didn't really, the SSC certainly recommended that it be officially convened and the working group being provided logistical support by the observatory. And finally, a very small proposal to investigate coronographic nulling, Gene Serabin at JPL. And this was to essentially leverage internal JPL funding for an potentially very important technology development. Of course, HACA, which is the official name of a high order adaptive optics proposal, also was approved for going forward to submitting funding proposals to NSF. Didn't work out this year, but hopefully the next time it will. And this is to replace a current, 360 actuator deformable mirror with one that has 10 times as many to enable extreme AO corrections for bright targets, and also to start thinking about optical adaptive optics in the future. Let me just summarize by saying there's no shortage of great ideas for improvements, upgrades, and new instruments coming out of this community. And the money that we have to as seed funding for all these things is significant, but not enough to really do the job properly. So it's really quite a balancing act, trying to have ideas being pursued to the point where something about them. Costs the standard 5 to 10% of the total cost of the instrument needs to be spent in order to know whether it's feasible and how much it costs. It's that intermediate stage, that is post-concept but pre-funding proposal, that's hardest to find the funds for. So funding for major instrument remains a serious challenge for everyone. And it's the kind of thing that we spend almost all of our angst-ridden meetings of the Science Steering Committee worrying about. Thanks.